Okay, so when we look at 3.3, the first thing that we're going to look at is where functions are increasing and decreasing. So let's imagine that we have this nice, smooth polynomial. Then there are times where the graph is going up. So if I cut the graph here and here, then this section is going up, this section is going up, this section is going down. Remember that we read graphs from left to right, so if we're going up, we're increasing. If we're going down from left to right, we're decreasing. Well, what can we determine, or what do we know about sections where we are going up? If we were to draw a tangent line anywhere in those sections, we would have a slope that's positive. Our slope would be greater than 0. Anywhere over here, our slope of our tangent line will be positive. So that means our first derivative will be positive, or our first derivative will be greater than 0. I'm just going to say positive. And our first derivative here is positive. Where we're decreasing, our tangent lines will all have negative slopes, so our first derivative will be negative. Remember that the derivative tells us the slope of the tangent line. So, well, that's good. So if we're told a specific point, we can check the value of that point in the derivative to see what the slope is, and we can tell if at that point, if that region or that area is going up or down. But how do we find out where we change from going up to going down? So notice here, if we go from a positive slope to a negative slope, then we've gone through a slope that's 0. And we've talked about critical points in the previous section. So this is going to be a critical point where our first derivative is 0. And the same thing here. To go from decreasing to increasing, or from a negative slope to a positive slope, then we're going to go through a slope of 0. Now, there are some other things that we could use. When we start looking on our number line, for this particular function that we're given, our domain is negative infinity to infinity. So some things that we're going to put on our number line, we're going to put all of our critical points. And all critical points are not necessarily going to be maximums and minimums. We could have other things. We could have places where we are undefined. We could have places where our derivative is undefined. So any type of critical point we're going to put on our number line. And then we're going to pick a test point in each interval to see in each interval, is our slope going up or is it going down? And how do we test that? What tells us about the slope? Our derivative. So we're going to see, is our first derivative positive or is it negative in each interval? And it's not going to be both. If we find the right breaks between increasing and decreasing, if we find all of our critical points, there's not going to be one point in that interval where we're positive slope, one where we're negative slope. Because if we go from a positive slope to a negative slope, then somewhere in between there, we would have to have a critical point. Either a peak, or we would have to have an asymptote or something. But if that interval is not broken up anymore, then none of those things are happening. So once we break up our interval using our critical points, everything in that interval is going to have the same characteristic as far as increasing and decreasing. So we just randomly pick a point, test the slope at that point, and that will tell us whether our interval is going up or down. So for this particular problem, we need our derivative. So our first derivative here is 2x minus 6. Let me go ahead and say this function does not go with this particular graph. This function on the right and this g of x are not the same function. So derivative equal to 0. So if we solve that, we would get x is 3. So that's our critical point. So that's divide our number line up, negative infinity to 3, and 3 to positive infinity. So we need to find out what's going on in each test 2 in the first interval, we could do 6 in the other interval. So if we substitute the 2 into our first derivative, we get 2 times 2, that's 4, minus 6 is negative 2. So our first derivative is negative in the first interval. So a negative derivative, that means a negative slope. We're going down. We are decreasing in that interval. Now we need to test the other interval. So if we plug in a 6, 2 times 6 is 12, minus 6. So in this interval, our first derivative is positive. If our first derivative is positive, that means our slope is positive. So we're going up, we are increasing in that. So if we're asked, where are we increasing, where are we decreasing? We're increasing starting at 3 and going to infinity. We're decreasing from negative infinity until we near 3. So that critical point, that's where we change from increasing to decreasing. It is possible that we could be increasing on both sides and still have a critical point there. But notice when we list increasing or decreasing, we always put parentheses on the edges. So let's look at another one. Let's take a look at this one and find out where are we increasing or decreasing. So we're told that we're only looking from 0 to 2 pi. So we're not going from negative to positive infinity. We're just looking in this region. So we need our critical point. So the derivative of x is 1. The derivative of cosine is minus sine. So we have a 2 times minus sine. So our first derivative is 1 minus 2 sine x. So to get our critical points, we set that equal to 0. We could add 2 sine x to both sides and get 2 sine x is 1. And then if we divide by 2, we get that is 1/2. If we consult the unit circle, then sine is 1/2 at pi over 6 and at 5 pi over 6. Both of those are values in the first rotation. So pi over 6 and 5 pi over 6. So that breaks our number line between 0 and 2 pi into 3 intervals. So we need a test point in each interval. So if you're good with radians, if you're good with pi's and stuff, you might say, okay, somewhere in between here we could do like pi over 12 or pi over 8, something like that. If you're not as good with pi's and fractions and stuff, you could say, well, pi divided by 6 is about 0.52. So anything between 0 and 0.52 I could use as a test point. So 0.3 could be a test point. Well, if this is about 0.52, and our next place is 5 pi over 6, which is about 2.6. And 2 pi in decimals is about 6.3. Then in terms of decimals, a value in between here we could use as 1, and we could use 4 over here. Again, feel free to use some of your standard angles in terms of pi, like pi over 3, pi over 2. Over here we could use pi, we could use 3 pi over 2, anything. But we can also do decimals. So remember, what are we looking for? We're looking for where are we increasing, which is where our slope is positive. And what tells us slope? The first derivative. And we're also looking where we're decreasing, which is where our slope is negative, or where our first derivative is negative, where we're going down. So we just need to evaluate the slope in each interval. So plug in our test values into our first derivative. So if we plug in a 0.3, we have 1 minus 2 times sine of 0.3. That's not a degree angle, that's a radian angle, so we have to make sure our calculator is in radians. I actually made this video earlier and accidentally got rid of it, and I had my calculator in the wrong units. So radians, so we're going to take sine of 0.3. The coefficient of that is -2, and then we have a positive 1 out front. So when we do this calculation, we get a positive value for our slope. Our first derivative is positive, which means we're going up, so we're increasing in the first interval. Now if we test the second interval, we take our first derivative and put in a test value. So 1 minus 2 times sine of 1. So sine of 1, the coefficient is a -2, and then we have a plus 1 out front. So when we do that, our first derivative is negative. So that means we're going down. Our slope is going down. So we're decreasing in this interval, which leads me to believe I'll probably be increasing in the next interval, but we need to test because there are exceptions. So if we put in a 4, sine of 4, the coefficient, plus 1, it's positive. Our first derivative is positive in this interval, so we're back to increasing. So we're increasing between 0 and pi over 6. We're also increasing between 5 pi over 6 and 2 pi. And then the other part, oops, forgot to erase that earlier. The other place we're decreasing, so we're decreasing in this interval, which goes from pi over 6 over to 5 pi over 6. So that tells us where we're going up and where we're going down for this function. Now let's do one more. So this one we don't have any restrictions, so we're back to going from -infinity to infinity. There's no place it's undefined, and we're not told just to look at a certain region. So to find out where we're increasing or decreasing, we need our derivative. So once we take our derivative, which again, that's our slope, we need to find out our critical points. Our first derivative here is never going to be undefined, so we only need to find out where it's 0. So we can add 24x squared to both sides. We can divide both sides by 24. And if we take the square root of both sides, remember when we take a square root, we have to include plus or minus. Now there are other ways we could have done that. We could have factored out a -24 and then factored x squared minus 1. But either way, we get critical points of plus and minus 1. So for our test points, we can use a -3, we can use a 0, and you could use a +4. Any number we want to, as long as it is in the interval that we're analyzing. So let's look at what happens when we plug each of these values in. So let's do this. So if we substitute a -3 in, -3 squared is 9 times -24. And when we add +24 to that, that's still going to be negative. So here our first derivative is negative. Negative slope, so we're decreasing in the first interval. And then from -1 to 1, we can plug in a 0. So if we put in a 0, 0 squared is 0. So that's 0 plus 24. So our first derivative makes a positive. So if our slope is positive, we're increasing. And then in our third interval, if we put a 4, we get 4 squared is 16 times negative 24 plus 24. Of course, that's going to be negative. So our first derivative is negative in that interval. So our slope is going down. So we're decreasing. So if we want to describe where we're increasing in that middle section between -1 and 1. We're decreasing on the edges. So from negative infinity approaching -3, we're decreasing. And then, oops, that was my test point, not my critical point. We go from negative infinity all the way to -1, and then from 1 to positive infinity. So we're decreasing here, and then we're increasing in the middle.